For section 8.3, we're going to look at something called simple interest, okay? So several definitions to start with, and then we'll kind of just play around with examples where we can show that we understand those definitions, and then in the next videos, we'll start looking at actual examples of calculating interest, okay? So first, let's talk about some definitions here. So first of all, what in the world is interest? Well, interest is the cost of borrowing money or the return earned on investment. So it kind of benefits you or hurts you depending on the situation. If you are borrowing money from some kind of lending institution, they're not going to let you borrow that money for free. You have to pay to borrow that money. The money that you pay is the interest. Okay. On the flip side, if you invest money, you're not just investing your money for it to sit there forever and ever and ever and ever. Basically, what happens is while your money is sitting in the bank may use it for other things, and you're going to earn a percentage back on that. So if you park money in the bank and let it sit there, it's going to earn interest so that 10 years from now, you're going to have more in than what you started with. Okay. So, in other words, interest is the price paid for using someone else's money or the reward for investing your money. Okay. So again, it can benefit you or hurt you depending on the situation, okay? It is a fact of life though, so try not to think of it as hurting as much as it does. Like if you get a car loan or a home loan, interest is just a part of that process, okay? Now, as far as the pieces that we need to really understand, the first big definition that we have is principal. The principal is the original amount that you borrow or you invest, okay? So if you borrow $10,000, $10,000 is the principal. If you invest $10,000, $10,000 is the principal. Next, we have an interest rate, okay? And this is where our work in 8.1 is going to come in handy. The interest rate is the percentage of the principal that is charged or earned as interest, okay? So if you get a car loan for 7% interest, that's the interest you're going to pay based on how much you borrow, okay? And if you invest money, you might get a 1.1% interest rate on your investment. That's going to be the interest rate. Okay. So it's always the percentage. When you think of these interest problems, the percentage is going to be your interest rate. One thing that is very necessary for us is when we're talking about interest rates, we're going to be given interest rates as percentages, but when we put them into our formulas, we need to put them in our formulas as decimals. Okay. Another thing that we need to kind of assume you're dealing with an annual interest rate unless you're told otherwise. So if you're getting a 7% interest rate, you get 7% that you're going to pay on whatever your principal is for the entire year. Okay. So again, assume an annual interest rate unless you are told differently. Okay. Now, after that, we have time. So time can be anything. Time can be days, weeks, months, years, okay? Generally speaking, we measure time in years unless we're told otherwise, okay? So you could have a loan for 5 years, you could have a loan for 5 months, but even if you have a loan for 5 months, we want to think of 5 months as how much of a year, okay? So kind of start thinking about time in years. There are some exceptions to that, but generally speaking, time is in years. And then again, if time is given to you in months, it needs to be converted to years. So again, if you're given a 6 month loan, think of that as 6 out of 12 months. Okay, so it's half a year. All right. And then another piece that we're going to talk about eventually in this worksheet is future value. So future value of a loan or investment is the value of the principal plus any accumulated interest over time. Okay. So if you have an investment, let's say you invest $10,000 today, in 20 years, that might be worth $12,000. So the value in that account with the principal that you started with plus any interest, that's your future value. It's something down the road. Okay. So for example one, what we're going to do is we're just going to label different pieces of problems. Okay. So problems meaning examples, I guess I should say. And then in future videos, we'll actually do some calculations. Okay. So for example one, let me rearrange my desk here. So in example one, it says label each value as principal, interest, interest rate, time, or future value. Okay. So for part A, we have that Dexter invested $25,000 at 3.1% interest. The value in the account after 5 years was $28,875. So we've got a lot going on here. First of all, let's just talk principal because that's the first number I see. So the principal in this case is how much Dexter invested. So Dexter initially started his investment with $25,000. Okay. And we're told he invested 21 or $25,000 at 3.1% interest. So the interest rate is 3.1%. Now remember, when we start to actually do calculations where we're calculating interest using a formula, we would write that as 0.031. We would convert our interest rates from percentages to decimals. Next, we have 5. So the time in years is 5. And then we're told that after 5 years, Dexter's account now has $28,875. So the future value here is $28,875. Now, to find the actual interest, okay, how much interest did Dexter earn into his account over 5 years? We have to do a teeny tiny little calculation here. So if you're not given a problem where you're actually calculating the interest, you can still figure out the interest by doing a different type of calculation. So if I take the future value and I subtract the principal, and I'm just going to call future value FV for now. We call it something later down the road, but for now, just FV. I can take the $28,875. I can subtract what Dexter initially invested, which was $25,000. And at the end of the day, Dexter, or rather at the end of 5 years, Dexter earned $3,875 in interest. Okay, that is not the actual interest calculation. You're going to see very, very soon that we have a bunch of different formulas that we're going to use. This is just labeling pieces to a problem or to a situation. Okay. Next up for part B, we have Deborah needed to borrow $30,000 to buy a car. She was able to get a loan at 6.75% that needed to be paid off over 6 years. After 6 years, Deborah will have paid a total of $42,150 for the car. Okay, so let's go through this piece by piece. First of all, the $30,000. The first number we see, that is the principal. So that is how much Deborah initially borrowed. Okay. She was able to get a loan at 6.75%. So the interest rate is 6.75%. And again, if we were actually calculating something here, like using one of our interest formulas, we would definitely convert the interest rate to a decimal. But for now, we can just say, hey, the interest rate is 6.75%. This needs to be paid off over 6 years. So time in this case is 6 years. And that's pretty typical for a car loan. Car loans are usually 5 or 6 years. Okay. Let's see. After 6 years, Deborah will have paid a total of $42,150 for the car. So the future value of the car is 42,150. And that seems staggering, but that's kind of the price of having to buy a car when you don't have the cash sitting in your bank and you have to borrow it. Interest is just a fact of that situation. So if we wanted to calculate the interest, remember we can take the future value and subtract the principal. So we would take the 42,150, subtract $30,000, and that tells me that Deborah paid $12,150 in interest alone. So over 6 years, not only did she pay the $30,000 for the car, she paid an additional $12,120 or $12,150 just in interest. That's a fee that just goes to the bank. Okay. So when possible, use cash. But if you don't have the cash and you got to buy a car, interest is just a part of that process. Okay. So again, the purpose of this video was just to introduce you to some of the terminology that we're going to use from now until really the end of this chapter. In the coming videos, we're going to start using different formulas. Okay. So we're going to look at different interest formulas.